All right, so we're going to look at how probability affects insurance because we wanted to give a good example of how you can understand a lot of things that, especially insurance, with probability. Now, we're going to start with life insurance because it's one of the easier things to calculate in terms of insurance if you know the probabilities. Now, sometimes those probabilities are hard to find, and I'll talk about that later, but when we have the probabilities, life insurance is fairly easy to calculate with. So, life insurance, how much the company charges you, sort of depends on the balance of the probability that you die and how much the company has to pay out. All right. Now, this is going to be a little bit morbid. I am fairly used to talking about life insurance, and so the probabilities, death probabilities. But hopefully you can sort of get over that initial reaction of, I should say, initial reaction of being bothered by the fact we're talking about death. But again, life insurance is insurance that if you die, you or your family gets paid money. Now, you can look up sort of the chance that you die. It always, not the chance that maybe you as an individual die, but there's all kinds of what's called actuarial tables. And you can look this up online, and I've given the link here. You could also, if you Google actuarial tables, the first thing that comes up is the Social Security Administration. All right, and that's the link that I have here. Now, if you click on that link to the Social Security Administration, they break it down, and I'm just going to kind of write a little bit about what they do. The Social Security Administration breaks the actuarial tables on males versus females. And then they break it down by age, and you'll see the age is, goes from 0, 1, 2, and it goes all the way down to, I don't know what the highest age they give is. It goes all the way down to 119, it looks like. Okay? So they don't plan on anybody living past 119. And then they give the probability that you die. Now, when a male who's just born, the probability that they die this year, well, it says 0.006680. And that's actually one of the higher probabilities. If you start looking down, when you get to 1 year old and 2 years old and 3 years old, it kind of drops off a little bit until you get to about 9 or 10 years old, and then it starts increasing again. All right, and again, the reason why this is a little bit higher when you're 0 is because of infant mortality stuff. Children are born with diseases and things of that nature. Okay. And by the way, the chances that you die if you're female, if you're 0 years old, is 0.00556. So apparently female babies are a little bit more robust or less likely to die anyways than male babies are. By this estimate. All right. So you can go look up, and I'm going to take the average, let's say 20-year-old male. 20 years old. Probably that male dies is 0.001085. And for females, it's actually quite significantly lower, 0.006. 0.0388 is what I see. All right. So the actuarial table gives the probability that males die. Now, I want to say this before I move on. The Social Security table, what that does is it gives you the probability of dying for all male 20-year-olds. All right, so this is the probability of dying for all male 20-year-olds. Now, if you are male and 20 years old, this might not be your probability of dying. Because in this group of male 20-year-olds are probably male 20-year-olds who have cancer, all right, and are on, their deathbeds, have cancer. Very tragic thing. And probably in this group are males who may have really, really dangerous jobs, maybe in, I don't know, in some part of Afghanistan where it's where there's a lot of insurgents and things like that. Okay, and same thing with the females. There might be some of the people over here may have really dangerous jobs. Some of them may be already sick. Some of them may smoke and not. So just because this is the probability for all 20-year-olds, if you don't smoke and are in good health and have no pre-existing conditions, your chance of dying might be significantly less than that. All right. If you are a non-smoking 20-year-old middle school teacher, your probability of dying is probably significantly less than that. All right. Now, here's the calculation point, and this is called an expected value. The expected value is actually the average or the mean of a probability experiment. All right, and it's basically the average amount if you did a lot of experiments. Okay, so for instance, if you had a million 20-year-old males, well, we know that the probability of them dying is 0.001085. So if you had a million 20-year-old males, you would expect, so expected number of deaths well, that would be 1,085. All right. Now this one came out to a nice whole number. But if you had, let's say, 1,000 people, well, then the number of expected deaths would be 1.085. Okay, and it's perfectly all right to get a decimal answer. All right, so expected value is the average of a probability experiment. Now, here's the real nice thing about expected value. We can change from expected number of deaths. Notice, by the way, the notation here is E with parentheses again, just like kind of my probability. This is the expected number of deaths. Well, we can change from expected number of deaths to expected payouts. All right. Now, what I mean by payout is how much the insurance company expects to pay out on average. So let's do this. A person buys $150,000 worth of life insurance. and that person's going to pay $200 per year. Well, forget about the $200 per year right now. Let's calculate the expected payout. So how much does the insurance company pay out on average for people who buy this much life insurance? Well, you pay out $150,000 if it happens. But it only happens 0.0012 of the time. So you take your however much your total payout is, and you multiply it times the probability of actually having to pay that amount. And so multiplying this, I get $180. This is going to be in dollars since the $150,000 was in dollars. So here's what that's saying. It's saying if the insurance company insures 50 million people, all right, on average, it's going to have to pay $180 per policy. So that's $180 times, 50 million. So like 9,000 million, which is 9 billion. But again, excuse me. So it's sort of the law of large numbers, right? If you have enough people, then how much the insurance company expects to pay out per policy is $180. Now, I want you to understand that doesn't mean the insurance company pays out $180 on every policy. They pay out $150,000 on some and zero on others. But they pay out zero on a lot of things, right? In fact, technically I'm leaving out something. I'm leaving out the fact that they pay zero on 99.88% or 0.9988 probability on zeros. Okay, so technically when you do an expected payout, you do all of the situations. You take the 150,000 times the probability that you pay 150,000 plus 0 times the probability that you pay 0. All right. But the 0 is never going to count on payouts, so I kind of left that off. But anyways, the insurance company either pays 0 or 150,000, but they pay 0 on 99.88%. They pay 150,000 on only 0.12%. So averages out that if they'd insured a bunch of people, per policy, you get about $180 per policy. Now, notice that once you've found that the payout is $180, that means the insurance company's profit, how much they make on the policy, their expected profit, well, that's just going to be the difference between how much they expect to pay and how much they take in. So their expected profit, in this case, is $20. All right? Now, this is the life insurance example where we only have two options. We have $150,000 that you're getting or your family's getting, or $0. Okay? And health insurance, I might look at this in just a little bit, but health insurance, there's a lot of options, right? There are people who go to the hospital and are charged $10,000, people who go to the hospital and are charged $100,000, and so on and so forth. All right? So here's what I want you to do. I want you to look up on that SocialSecurityAdministration.gov site the typical 18-year-old female, find that probability of dying within the year. Okay? And then determine first what's the expected payout for that person. And then think about if they bought insurance worth $200, how much the insurance company would profit off of that. So push pause, look those things up, and find it. All right, so what I've seen, so if I'm looking for the expected payout, we can take the total, 150,000. The chance that we get paid out 150,000, which is the same as the chance that the person is dying, is 0.000318. By the way, you could do this plus 0 times 0.99, what would that be? 9682. I think that's right. All right, but obviously the second part is going to be 0. So the expected payout is $47.70. Right? So for the average 18-year-old female, the insurance company only predicts that they're going to pay out $47.70 per policy. Okay? Notice that if the insurance company, if the expected payout, put an E there, expected payout is $47.70, that means the expected profit on this female, this 18-year-old female, well, take 200 minus that. So I got $152.30. All right, so in this case, they would make a huge amount of money. Now, I will say the insurance companies don't mark up that much. There's too much competition in life insurance for them to do that. They wouldn't mark it up by, what is that, 300% off the other payout. They more likely mark things up about 5%. But I'm making the point that these probabilities matter. All right? So here's what I want you to do. I want you to calculate the following example. Again, push pause, read this, and try to figure it out. All right, so this one we don't have any price, and there's a reason, amount that you're paying for, and there's a reason for that. But we want to find the expected payout. Expected payout. Well, the total payout is this much, 500,000, and the probability that that happens, that you actually have to pay 500,000 is 0.0021. And then obviously there's always this implicit, even if you don't write it, there's a 0 times the other one, right? If you die, you get a 0.0021 chance. If you don't die, you have a 99.79% chance. So expected payout here would be $1,050. Okay. Notice that, again, even though this is a fairly small probability, that is a huge jump from the last example. All right. And oftentimes people wonder why there's these big jumps in life insurance. Well, it depends on your probability of death plus the amount you're insured for. Okay? So, in the previous example, our probability of dying was lower, and much lower in fact, and our payout was lower as well. So, probability, the insurance, the amount the insurance company is going to charge you, and the amount that the insurance company expects to pay out is just based on the probabilities and the amounts. All right. So most times, what insurance companies do is they calculate the expected payout, just almost identical to what we did, except their probabilities are slightly different, right? I mean, if you're a healthy 20-year-old, you might get charged less than an unhealthy 20-year-old for life insurance. You can't do that with health insurance for legal reasons, but for life insurance, you can do that. So what the insurance company does is they check and calculate your expected payout, and then how much they charge you is typically like a standard percentage over the expected payout. So they're going to charge you, I just chose a number at random, I don't know what the actual markup is on insurance companies, but 5% over the expected payout. So what they do is they take your expected payout and do 5% over that. Remember, 5% over that is 105% total. So take 1,050 times 1.05. So they would charge you $1,102.50. And this is for a year's worth of insurance, okay? So if you, at the beginning of the year, bought all your insurance, they do $1,102.50. Now, I want to point this out because a lot of people think, somehow the insurance companies are evil or something like that. What they charge you is weird. I want to just point out, what they charge you is not out of the blue. Okay? What they charge you is just based off the probabilities and the amount that you want to be insured. And that goes for everything. All right? When they talk about health insurance, life insurance, all these things, it's just a matter of the insurance company taking those actuarial tables and deciding what happens. Okay? Not that they're manipulating the money. They're just saying, well, what's the probabilities that we're going to pay out these amounts? What's the probabilities we're going to pay out these amounts? So, for instance, in healthcare, what they would do is they would say, well, we know there's a lot of different amounts we could pay in healthcare. So maybe we could pay $20,000, maybe we could pay $15,000, maybe there's procedures for $10,000, maybe there's $5,000, and I'm just making this up, and maybe there's the chance that we put 0. And each of these things might have a different probability, all right? Maybe this has a probability of 0.001 of happening. And this has a probability of 0.01 of happening. And this has a probability of 0.05 of happening. And this has a probability of 0.25 of happening. Right? And this has a probability of whatever's left over. Let me just do this, calculate this for an example. So this would be 0.689. And so if you walk in, what they've calculated is that you have a 0.001% chance of spending $20,000, or between $20,000 and $15,000. You have a 1% chance of spending between $15,000 and $10,000. And maybe there's a really small percent chance out here or something, I don't know. Maybe there's a chance you spend between 15 and 10,000, 1%. 10,000 to 5,000, there's 5% chance you do that. Between 5,000 and 0, there's 25% chance. And paying 0, there's a almost 70% chance of that. And again, I'm making up these numbers off the top of my head, but this is how the calculations work. And so what they're going to do is they're going to calculate the expected payout by taking the 20,000, multiplying it times its probability, take the 15,000, multiplying it times its probability, and so on and so forth till they get to the 0 multiplied by its probability, and then they add them all up and get an expected payout. By the way, I'm just going to do that real quick. 20,000 times 0.001 plus 15,000 times 0.01 plus 10,000 times 0.05 plus 5,000 times 0.25 plus 0 times 0.689, and I get $1,920. And so if they calculate that these are the probabilities, then what they're going to do is they're going to charge $1,920 to you. All right. Now I do want to say for health insurance, and we're going to talk about this in the next section, we do have to make sure we understand that while life insurance you buy as an individual, health insurance, even while you're paying as an individual, it's really a collective idea. And we'll talk about that later. So if your probabilities are less than these, it really doesn't matter in terms of health insurance. They're going to still charge you the average amount. Okay, that's all I'm saying. So I hope you understand a little bit about expected payouts and how insurance companies work. Okay? And in the next section, we're going to talk a little bit more about insurance and in regards to health insurance in particular.